Hello, in this presentation I will talk about the main criteria for selecting an industrial robot. The aims of the presentation are, on the one hand, to know what are the main criteria to select an industrial robot, being the application for which is going to be used one of the most important criteria that will mainly affect to the robot type. On the other hand, we will also understand in this presentation the importance of other criteria such as payload, number of axes, work area, accuracy and precision, as well as your limits in position, speed or acceleration. In order to select a robot, here I'm showing some of the main criteria that will allow us to reduce the number of options in order to select the most appropriate robot. One of the main criteria, as I have mentioned before, is the application for which is going to be used, because it will mainly affect to the type of robot to use. Then we will also have other criteria such as payload, number of axes, work area, robot accuracy and precision, as well as joint limits. All these criteria will help us to reduce the number of options to a few robots. The final decision will probably depend on other criteria such as the price. This is something I will mention at the end of the presentation. So, as I have mentioned, the application will basically determine the type of robot to select, since some robots are more suitable for some applications than others. Classic robot manipulators are suitable for manipulation applications, welding, painting, and other applications. And they have a great flexibility and they are dexterous to load or unload materials. The SCAR robots are suitable for assembling applications with a lower cost than the previous articulated robots, and also with a reasonable good work area. Cartesian robots are very appropriate in applications requiring a high payload capacity. On the other hand, Delta robots are ideal in industries such as pharmaceuticals, electronics, and food, thanks to their great precision and speed. Finally, in applications where the robot has to work with humans, collaborative robots are probably our best option. The payload of a robot defines the maximum capacity to carry a load. The actual maximum weight of a load will depend mainly on the distance to the robot flange, since the important thing in the end is the maximum torque that the robot is capable to generate. In this sense, also, the weight of the tool and other accessories must also be taken into account for this payload capacity. Robots with the highest payload capacity are Cartesian robots. Then we have manipulator and collaborative robots. And finally, with a significantly lower payload, we can find SCARA and Delta robots. The number of axes of a robot will mainly affect two other criteria such as the work area and also the price. However, I think it is important to differentiate between robots that have 3 or 4 axes, such as parallelogram robot, SCARA, Delta robots, or Cartesian robots. These are robots that in general have a smaller workspace than manipulator or collaborative robots, which generally have 6 or 7 axes. The number of axes will not only affect to the work area, but also to the dexterousness to perform the same task. So the robot will be able to perform the same task with or from multiple configurations with higher number of axes. That will help us also to avoid joint limits. Here I show typical work areas for the most common robot types. The work area is a very important aspect to consider that will help us to select the correct robot. The larger the work area, the greater number of applications that the robot can that robot can be used. Manipulator robots have a typical work area like the one shown in the figure, being able to work behind the robot, while parallelogram robots have a smaller work area for similar dimensions. Delta robots typically have a work area as the one shown, like a 3D parabola. Cartesian robots have a cubic work area, as they are, as you can see, very simple. Scarab robots have a work area like the one shown, similar to the manipulator work area, but containing the XY plane, with the possibility for having a height control. Finally, the work area is not, if the work area is not enough, then you can find some solutions to enlarge such work area by mounting robots on a mobile platform or some rails. Accuracy and precision are two different concepts that must be also considered in order to select a robot. Industrial robots are usually precise and accurate, but these terms are relative to the accuracy and precision required by the application. If a robot is not precise, the positions reached will be different from the ones programmed. While if a robot is not accurate, each time it tries to reach the same position, then it will appear as there's some kind of noise associated with such accuracy. Joint limits is another important criterion to consider. Joint positions limits will directly affect to the work area, but in addition to the position, we must also take into consideration the maximum joint speed. These speeds are generally different from each of the robot axes. And in addition to the maximum speed, it is also very important to consider the acceleration, because it affects to the time that it takes to reach the maximum speed. Once we have significantly reduced the number of options based on the previous criteria, then other criteria come into play, and they are actually the ones that end up helping us to take the final decision. Obviously, the price of a robot is a very important aspect to consider, as well as the maintenance that the robot requires and or its ability to communicate with other machines such as a PLC. Also the software used and the weight of the robot, especially if the robot has to be mounted on a rail or a mobile base. Also, the IP protection level. It's a very important aspect to consider if the robot has to work in a dusty environment or work with liquids. This might be actually a very huge difference depending on the environment the robot has to work. And finally, the robot manufacturer will finally affect to the final decision, because in most of the cases we prefer to keep the same brand as the ones already existing on a factory. In this presentation, I have mentioned the most important criteria for selecting industrial robots. Thank you very much.